If a particular user has logged into our website to read a particular blog post, then how can we suggest the related blog post to him using the techniques like machine learning and natural language processing is what we are trying to understand as part of this video series. To be able to compute the relatedness between the two blog posts, we should first be able to convert those blog posts into numerical format. The process of doing that using the concepts like count vectors we have already seen in our previous lectures. The link for all these concepts I'll put it out in the description box. In this video, we are going to write a code to implement the concept of count vectors using one of the Python library which is Sklearn. Hi, this is Aditya. I do videos on latest technology trends and their technical implementations in the field of digital marketing. If you are interested, please subscribe to my channel. Let's get started with the presentation. Before writing the code, let's first try to understand the Python machine learning ecosystem. So these are the general libraries which we use whenever we do machine learning programming as part of Python. So the first library is NumPy library. So using NumPy libraries, we can create the arrays. Okay, so why should we use NumPy to create the arrays? It's because of the fast processing. We might want to sort the array, split it in certain way, or copy one array into another array. So in this library, they have optimized all these kinds of operations to perform in a better way. Okay, so that's why we use NumPy library. And then coming to the SciPy library, so it takes the input of this NumPy array and it performs certain scientific calculations on top of it. Like for example, it might be solving the linear equations or doing the differentiation or integration or any kind of engineering calculations or scientific calculations on top of the arrays, which is NumPy arrays. So all the functions which does such kind of operations are stored as part of SciPy library. Then the next library which should be aware of is the scikit-learn. So as part of this library, we have all the machine learning algorithms and the feature extraction and other kind of functions. Okay, so it takes the input of these SciPy scientific calculations, it takes help of these libraries, and using these libraries, it will perform certain machine learning algorithms. And the next library which we generally use is matplot library, which is used for doing some bar charts or pie charts. So these are the four most used libraries as part of machine learning when doing Python programming. So there are two approaches which we can follow while we are doing the machine learning programming. So one approach is the bottom-up approach and other approach is top-down approach. In bottom-up approach, what we do is we get a clear understanding of all these libraries, we get a clear understanding of what is the Python syntax, and then we try to solve the business problems using that understanding which we have. So this is the bottom-up approach. So in that way, we get a thorough idea on all these libraries and what are the functions being used, and we also have a good hold upon the Python language, and then we go ahead and try solving the problems. But it takes a lot of time to learn things in this way. And also another disadvantage is that it feels as if we are learning all these for the sake of learning, but we do not have an end goal as to what to achieve out of all this in our mind. So as opposed to this, there is another way of learning which is top-down approach, wherein we will have a goal to solve in our mind. We have some business problem and we will go through these libraries to learn them to such an extent so that we'll be able to solve our business problem. So we will neither master the Python programming nor we will master any of these libraries, but still we keep learning them in an explorative way and get the information needed to solve our business problem. And in the process of doing so, we also get to learn these libraries. So I, in my all the lectures, will follow the top-down approach because I feel it is the most natural way of doing it. So in this way, the con is that we will not master everything initially, but we will go ahead and learn the things in an explorative way, and on practice on solving multiple business problems, we get to master the Python language and also these libraries. So with that said, we'll have a quick recap of what we have discussed about count vectors and then go ahead and see how to implement the code using this explorative way which I have discussed till now. So just as a quick recap, so these are the three blog post examples which we have taken, blog 1, blog 2, blog 3, and then in the next step we have done the cleansing, and in the cleansing part we removed all the unnecessary words which are not related to the topic. And then as a third step we have prepared the vocabulary. So we have collected all the unique words which are used in this cleansed text and we have prepared the vocabulary. And then as a last step we have created the count vectors. So what we have done is each of these words in the vocabulary, how many times it has been repeating in the blog. So that we have marked. If it has repeated once, we have marked it as 1, and if it has not repeated or not occurred at least once, we have put it as 0. So that's how we got these three vector representations. Now this is what we are going to code in our Jupyter notebook. Let's see how it can be done. So as we have already seen, the first thing which we need to do is create a vocabulary out of our blog post, which means that we are trying to extract the features out of the given blog post. So this is the feature extraction part, and we have already seen the Python ecosystem which we have discussed, and the feature extraction part of it is there as part of scikit-learn package. So let's go to Google and search for scikit-learn. Then you'll get the scikit-learn.org website wherein all the official documentation of this package is documented. Okay, so let's go to this scikit-learn website and see what all things we can do with this. Okay, so we have the algorithms which are related to classification. Classification is one type of machine learning algorithm, and we have the regression kind of algorithms and clustering kind of algorithms, and we can also do the dimensionality reduction, model selection, and pre-processing. As part of pre-processing, we have feature extraction and normalization. So this feature extraction is what we are talking about. So let us just open this feature extraction part here. And in this feature extraction, what we are interested in is about the text feature extraction. So let's go to the text feature extraction. So this is how we can explore the package and go to the point which will help us to solve our business problem. So text feature extraction is what we are looking for. So that problem we should know, and we should also know where to look. So we knew that we have to look into the scikit-learn package. So that's how we have arrived upon here. Here we can read this entire document and get a good understanding about only this particular thing, which is the text feature extraction, which is required to solve our business problem. Here they have given an example of how the count vectorization can be done. So we will try to implement this code in our Jupyter notebook. So to do that, just open the search and type for Jupyter. So, and open this Jupyter notebook. You should first open this Anaconda prompt, and it should then open the Jupyter notebook. Okay, so we are on it. So click on new here and then enter Python 3. Okay, so let's start coding now. So all we need to do is just the copy paste thing. So this is the first statement which we need to copy paste. So when we copy paste, let's try to understand what is this all about. So from sklearn feature extraction.text, we are importing the Countvectorizer. So if we read through the documentation, it has been mentioned that Countvectorizer is a class. It implements both the tokenization and occurrence. So the tokenization is what we talked about, vocabulary creation. So finding what all unique words are there in the blog post and then creating a list of all those words, that is called as tokenization. And occurrence is counting how many times each of those words has occurred in a particular blog post, that is the occurrence. So both of these functions are combined into this particular class, that is what they're telling. Okay, so that class we are importing so that we can use those functions and create the count vectors. Okay, so the importing part is done. So as a next step, what we can do is these things. So here vectorizer is just a variable. So in Python we need not declare it as anything. So we can just start using the variables and automatically the type and everything will be handled by Python. Okay, and we are initiating this class which is Countvectorizer. Okay, so then all we need to do is copy paste this code. Okay, so this is called as corpus. Okay, so as we have already discussed, what is the corpus? It is just the collection of all the documents. Documents in our case is blog posts. So corpus is nothing but the collection of the blog posts in our case. So what we'll do is we already know what all blog posts which we need to take care, right? So we'll just copy paste our example blog posts here. So this is our blog post one. So let's copy this blog post and paste it here. So all this blog post we have put it as part of an array which is called as corpus. Okay, so this corpus is just a collection of all this blog post in the form of array. Okay, so then we will copy paste the next line, which is this one. So as part of this, what we are doing is we are just calling this vectorizer variable, and we are calling this fit transform function, and we are passing this corpus as an argument to it. And this returns something which is stored as part of this X. So this is all we need to do to create the count vectors. So now let's try to see what is the vocabulary of the words it has created from these three blog posts which we are given here. Okay, so to do that, if you read this documentation, right, you get to know that we can use this get features function. Okay, so this one we can use. Okay, so this should give us what all features it has extracted out of these three blog posts, and features are nothing but our vocabulary which we have created in our PPT. So to execute this code which is there in this particular cell, we click on Shift and Enter, and you will get the response. So as you can see, we got an error. It says that count vector object has no attribute, get feature names out. Okay, so there could be some difference in the libraries. So we can just Google out about that error, and we'll find that we can use get feature names instead of underscore out. So this should work. Okay, so here we can see that these are the unique words which it has created. So as we can already see that the words like and, are, his, and all these words which are not related to the topic, right, those are not removed from our list. Okay, so that is why we are getting such a big list. So the next thing which we need to do is to see how can we remove those unrelated words. Okay, again we can go through the documentation and we can see that they are calling it as stop words. Okay, and there is a syntax also to remove all these stop words. Okay, so we'll just give this stop underscore words. Okay, if you completely read through the documentation, you will get it. Okay, so stop underscore word equal to English. Okay, so then it will consider the stop words which are there in the English. Stop words are nothing but the most repeated words which doesn't add to any topic like and, are, his, something like that. So all those things it will remove just by giving this argument. Okay, let's see what it gives now. Again, I'm clicking on Shift Enter, and now it has removed all the unrelated words. It has cleansed the text and given the output to us. So what have we done till now? So first we have initialized this vector and we have passed certain argument to it, and this is the object which is holding this instance of the class. Okay, this is called as vectorizer. And what we have done is we have created an array which is the collection of all these documents or blog posts, and then we have used this particular object and we have called this fit transform, and we have passed this corpus to this particular function. Just by executing this particular statement, we have done two things. The first one is, as we have seen here already, the list of count vectors. This we have got it. Okay, and this we have got, and this response of this entire count vectors is stored as part of this X. So we haven't printed that yet, but we'll see how to print it. And what we have also got is the list of vocabulary which we created here. So that also we have got it here. And this list was stored as part of some variable in this particular class, and that list can be retrieved by executing this get feature names function. Okay, so there is a variable in this particular class which holds all these values, and just by executing this get feature names function, this is just printing all those values in that particular variable which is residing in this particular class. So all that is abstracted from us. Okay, so all we see here is we just have a class and we just have this get feature names, and then by just executing this method some values are printed. Okay, so these values are the list of vocabulary words which we have. Okay, so now let's try to see how do we get the count vectors. Again, we can just read through this documentation here and we will know that the count vectors can be printed in this way. So x.toArray. So just by giving this x.toArray, we'll be able to print the count vectors. Okay, so these are the count vectors which we got. Okay, which would be similar to what we have done here. Okay, so for each of the blog post we have got the list of count vectors, right? List of zeros and ones. So similarly for each blog post here we have got the corresponding number representation of it. Okay, so let's try to understand what is this statement now. Okay, so what we are doing is x.toArray. So why should we do this? Let's try to understand that. So since we are doing all this in an explorative way, right? So first thing which we need to understand is what is this particular thing returning? Okay, so what is the data type of it? Once we know the data type of it, then we can go to that particular data type and see whether it has this method toArray or not, and we can know more about it. So whenever you don't know any data type, so you can just print the data type of it using this type function in Python. So just use the type function and type x, you print it, then you will know what is this class. Okay, so this is the data type of this x which is being returned. So the type of this x is one of the class which is CSR Matrix in SciPy library. Okay, so we can just find out in Google more about what is this class and what is its behavior and all that. Okay, if we just Google, we'll get more details about it, and then we can go here into this documentation and try to understand more about these things, like what is the implementation and more details we can read about it. So this is how we explore the things. Okay, so as of now, all we need to know about is this is one class and these are the methods which are there as part of this class. Okay, and if we find the toArray here, so we have toArray also. So you can read this documentation thoroughly to understand more details about it. But to summarize it, what is it, right? CSR matrix is nothing but compressed sparse matrix. So to understand this, we need to first understand what is sparse matrix. Okay, so here we have the features, right? In this get feature names, we have the features here. So let's print this also. Okay, so I have printed these. So these are the features which we have, and for each of these features we have the mathematical representation for this particular document, right? So now the features are just around 10 or 11. But if we have more number of features, like let us suppose 10,000 of them, mostly we will have zeros. Like we might have in those 10,000 features like only 10 ones and rest all others are zeros, right? For each of the blog post, maybe only like 50 words are there, but all other 10,000 words are zeros. So such a representation of matrix is nothing but this two-dimensional array. So this entire thing is matrix. So this is one array and this is another array, and then all this array of arrays is called as a matrix. Okay, so this entire thing is a matrix representation, and then we have lot number of zeros in that particular matrix. So if we have such a two-dimensional array or a matrix, then if we want to perform any of the calculations, like for example matrix inverse or any kind of matrix operations or any kind of scientific operation on that particular matrix, it will become very complicated because of the huge number of columns which it has. So as we have already seen, in those huge matrices, what will happen is there will be huge number of zeros in sequence. So maybe like there are 5,000 zeros in a particular one-dimensional row, right? So the thought is, can we compress this matrix somehow and reduce the dimensionality of it so that we have a smaller matrix to work with. So that kind of transformation of this two-dimensional array, which is a huge array, into a compressed kind of format by running some compression algorithm is called as this compressed sparse matrix. Okay, so as a result of executing this particular vectors, right, of this particular thing, the result what we have got is the compressed matrix. Okay, so then this is the compressed matrix. Now we need to know what is the actual two-dimensional array, because what we have printed here is the two-dimensional array, the actual matrix of the count vector representation, right? So that actual count vector representation we want to know. We don't want to know what is the compressed format of it. So how to get the actual representation of this matrix from this compressed array, right? So to do that, we will execute this toArray function. So if you execute this toArray on the compressed matrix, it will transform that compressed matrix into this two-dimensional array and give the output to us. Okay, so finally what we have done as part of this video is we have executed the code to actually get this count vectors. So whatever we have discussed here, that we are able to execute in the form of code. In our later lectures, we'll work upon this more until we get a production ready code. Thank you.